The Embraer 145 is equipped with an audio integrating system, which allows two-way interphone communication between the cockpit crew members, the cockpit crew, and the forward flight attendant or rear flight attendant, between the cockpit crew and the front ground crew station, and or the rear ground crew station. It also allows for voice intercommunication via the aircraft radio communication systems and monitoring of all audio outputs of the communication and navigation systems. To provide intercommunication, the headsets must be connected to the Interphone jack receptacles. Boom connects the headset microphone plug, and headphone HDPH connects the headset receiver plug. The press to transmit buttons, PTT, on the pilot and co-pilot control yokes and on the observer jack panel must be in hot mic position to activate the microphones. On the digital audio panels, the interphone button must be released and turned for adjusting the side tone and volume level of the microphone. When the knob is turned to the right, the side tone and volume will increase, and when turned to the left, the side tone and volume will decrease. To adjust the output volume to the headphone knob must be adjusted. Turning this knob to the right will increase the volume, and turning to the left will decrease the volume. If the press to transmit buttons on the pilot and co-pilot control yokes and on the observer jack panel are in the off position, the microphones will be de-energized. To permit radio transmission and communication, a source must be pre-selected on the digital audio panel. For ground operation at either the front or the aft ramp station, when the cockpit call button is pushed, a high-low tone is generated in the passenger address amplifier and provides amplification to the cabin loudspeakers. The digital audio panel supplies two-way interface between audio signals from cockpit or ground stations or via interphone link. When selected, the press to transmit button PTT on the control yoke and the ground headset to hot mic permits communication directly between cockpit and ground stations. The airplane is equipped with an audio integrating system, which is controlled by 3 digital audio panels. 2 are installed in the main panel, and 1 on the right-hand rear console. The pilot digital audio panel is installed on the main panel, left-hand side. The co-pilot digital audio panel is installed on the main panel, right-hand side, and the observer digital audio panel is installed on the right-hand rear console. They allow for two-way interphone communication between the cockpit crew members, between the cockpit crew and the forward flight attendant or rear flight attendant, and between the cockpit crew and the front ground crew station, and or the rear ground crew station. It also allows for voice intercommunication via the aircraft radio communication systems, and monitoring of all audio outputs of the communication and navigation systems. The airborne audio subsystem controls the output of the communication and navigation receivers into the flight crew headphones and speakers. It also controls the output of the flight crew microphones into the communication system. The digital audio panel receives digital audio from the integrated communication computer and the integrated navigation computer and transmits analog signals. The digital audio panel has 5 transmit buttons: COM1, COM2, COM3, HF, and the passenger address amplifier labeled PAX. The applicable button must be pushed in to connect the microphone to the appropriate transceiver or interphone channel. In the emergency mode, the tuning backup control head provides a backup for both RMUs or all radio system buses. The operation in this mode is identical to the normal mode, except that the reading of the radio system bus and comparison of the information to the displays does not occur. Besides, whatever frequencies are shown in the display are sent to appropriate COM and NAV units, along with a bit which is set in the data word. This bit tells the remote radios to ignore radio system bus tuning information and accept only tuning from the auxiliary tuning posts. Note, only selection of NAV2 and COM2 frequencies are possible in this mode. The COM, HF, NAV, ADF, and DME audio control functions as an audio connect-disconnect switch and a volume control. The audio is connected and the volume can be adjusted when the control is in the unlatched position, and the maximum volume level is at the full clockwise position. The audio is disconnected from the on-side speaker and/or headphone when the control is in the latched position. The microphone mask selector is used to choose which microphone is connected to the transmitter. When this switch is in the latched position, the headphone microphone is selected. When the switch is in the unlatched position, the oxygen mask microphone is selected, and the speakers are switched on. The ident voice control is used to filter the VOR and ADF audio signals. In the ident latched position, the control enhances Morse code identification. In the voice unlatched position, the audio is filtered to reduce the Morse code signal for received VOR ILS audio. ADF audio is unaffected when the voice mode is selected. The speaker and headphone controls are used to adjust the overall on-side speaker and/or headphone volume. They function in series with the individual audio source controls. The side tone level control is used to prevent undesirable feedback of speaker side tone audio into the transmitting microphone. When transmitting, both the on-side and off-side speaker side tone audio levels are lowered. In addition, the off-side headphone and side tone levels are lowered. When the side tone control is in the latched position, the on-side cockpit speaker is turned off. And when the control is in the unlatched position, the on-side cockpit speaker is on. The Interphone volume control adjusts the on-side headphone audio level when the Interphone function is used. The marker beacon volume control is used to adjust the marker beacon volume to the speaker and headphone. The volume cannot be adjusted below an internally preset level. When the marker beacon volume control is in the latched position, the on-side cockpit speaker and/or headphone is turned off. And when the control is in the unlatched position, the on-side cockpit speaker and/or headphone is on. The marker beacon mute is used to temporarily silence the marker beacon audio. When the mute button is momentarily pushed, the audio is muted. The audio remains muted for the time it takes the aircraft to leave the influence of the marker beacon. Then it resets, unmutes, in preparation for reception of the next marker beacon. The marker beacon receiver high sense, low sense sensitivity is controlled by rotating the mute control selector to high sense or low sense position. Static dischargers on the Embraer 145 are installed on the following flight control surfaces: the ailerons, the elevators, and the rudder. Static dischargers are also installed on the wingtip fairings, on the vertical stabilizer rear fairing, and on the nose landing gear strut. Their purpose is to discharge the airplane electrostatic charges. The static discharger is a graphite-coated rod of aligned fibers with a carbon composite tip, which discharges the accumulated electric charges into the surrounding air. The nose landing gear static discharger is an adjustable steel cable static discharger rod with a brush of fine steel wires, which discharge the accumulated electric charges to the ground during the touchdown phase and on ground. A solid-state cockpit voice recorder, SSCVR, is installed in the aircraft rear electronic compartment. The function of the cockpit voice recorder is to put all the conversation between flight crew members, flight crew and ground stations via radio link, observer station, and cockpit area into the memory. An impact switch is installed next to the cockpit voice recorder to cut the power supply to the solid-state cockpit voice recorder unit in the case of an aircraft crash. This unit has a red lamp and a reset switch. The red lamp will light up when 5 Gs is exceeded. When the reset switch is pressed, the red lamp goes off and the subsystem goes back to the normal condition. The crash and fire-resistant solid-state cockpit voice recorder is a 4-channel fixed memory recorder with a continuous recording duration of 120 minutes. An underwater locator beacon is installed on the cockpit voice recorder. The underwater locator beacon is a battery-powered device which radiates a pulsed acoustic signal when in contact with water. When the underwater locator beacon is activated, it transmits a 37.5 kHz pulsed acoustic signal. The solid-state cockpit voice recorder control unit is installed in the cockpit overhead panel. This unit provides interfaces with the solid-state cockpit voice recorder for access to such features as test, erase, and status of the unit. When the test switch is pushed, the subsystem performs a functional test to ensure the integrity of the subsystem. A successful self-test result is shown by an activated status LED for 1 second on the control unit, and a 2-second 800 Hz tone is generated to the headphone output. To start the erase sequence, the parking brake must be on, the landing gear logic must sense a weight on wheels condition, and the erase switch has to be pushed. When all the previously recorded datas are successfully erased from the survivable memory, a 3-second 400 Hz tone is generated to the headphone output. The solid-state cockpit voice recorder receives the signals through the 3 digital audio panels, DAPs, which are the pilot panel installed on the main panel left-hand side, the co-pilot panel installed on the main panel right-hand side, and the observer panel installed on the right-hand rear console, and through the area microphone installed below the standby compass. The integrated automatic tuning system's main purpose is tuning of the communication and navigation radio modules during normal or emergency operation. For this purpose, it has 2 radio management units, RMU, installed on the main instrument panel, a tuning backup control head installed on the center pedestal, 2 integrated navigation units, INU, and 2 integrated communication units, ICU, installed in the forward avionics compartment. The radio management units remotely control the ATC Mode S and communication modules in the integrated communication units, and they also remotely control the NAV, ADF, and DME modules in the integrated navigation units. The aircraft has 1 tuning backup control head, which provides for an alternate method of remotely controlling the right-hand communication and navigation modules, which are normally controlled by RMU number 2. The integrated navigation and communication units are complete, self-contained COM-NAV systems. Internally, these units have COM-NAV modules, responsible for communication and navigation tuning and operating mode selection. For radio system tuning, 2 radio management units, RMU, are installed in the cockpit. RMU-1 normally controls the left-hand radios, and RMU-2 the right-hand radios. The RMU is the central control system for the VHF communication system, the VHF navigation system, the ATC transponder system, the ADF system, the TCAS system, and the MLS if installed. To perform this function, the RMU has 2 COM-NAV frequency transfer buttons, 10 line select keys, 8 function keys, a large and a small control knob. During system power-up, a power-on self-test automatically starts and lasts for about 50 seconds. This test also starts when there is a power failure for more than 10 seconds. It can be terminated by pressing the test button on the RMU. After a successful power-on self-test, the main tuning page will be shown automatically. However, a system test can be performed manually during any time, either on the ground or in flight. Radio management tuning is performed as follows. A COM or NAV frequency can be pre-selected by pushing the applicable COM or NAV line select key. The desired frequency can then be entered by using the tuning knobs, and as soon as the applicable transfer button is pushed, that frequency will become active. By pushing the storage button, pre-selected frequencies can be directly stored into the RMU memory. The squelch button on the RMU opens the squelch circuit and allows any signal present in the radio to be heard. The dim button allows for selection of the display brightness via the small tuning knob. Pressing the page button on the RMU allows access to additional pages, which are the COM memory page, used to preset up to 12 COM frequencies on 2 pages, the NAV memory page, used to preset up to 12 NAV frequencies on 2 pages, the ATC TCAS page, used to set ATC TCAS parameters, the navigation page, which provides a backup navigation display, the engine pages 1 and 2, which provide engine and certain airframe system backup indication, and the maintenance page, which provides information for maintenance personnel on the ground only. The backup tuning control head will also perform a power-on self-test during power-up. If the power-on self-test is successful, the tuning page will be shown automatically. But if there is a failure, the NAV display will show an event code to identify the fault. Should a failure in RMU number 2 occur, the emergency mode can be set through the emergency key. When this is done, the emergency annunciation will be shown and full control will be transferred to the backup tuning control head. And an auxiliary on annunciation will be shown on the RMU number 2 ComNav windows to indicate that the control has been transferred. The passenger address and entertainment system includes the following 3 subsystems. The passenger address and cabin interphone system, which provides communication among pilots, observer, flight attendant, and ground crew. The passenger loudspeaker system, which allows the flight attendant and flight crew to communicate with the passengers and other flight crew members. The pre-recorded announcement system, which provides the flight crew and passengers with safety information and in addition can play music. The passenger address system provides communication among pilots, observer, flight attendant, and ground crew. It also provides announcements from pilots, observer, and flight attendant to the passengers. The passenger address system includes the following components. The public address amplifier, a unit located in the left-hand forward electronic compartment. The public address amplifier sends and receives signals to and from the flight deck, attendant handsets, broadcasts pre-recorded announcement systems, establishes the priority among the input signals from the several sources, and then drives these signals to the proper cabin loudspeakers. It also generates the logic for aural and visual annunciator and the chimes for attendant, passenger, and flight deck call. The intercommunication control unit is installed in the overhead panel. When the emergency button is pushed, emergency communication with the flight attendant station is possible. If the emergency button is pushed again, this mode is cancelled. When the light flashes and a chime is audible, an emergency call from the flight attendant has been received. When the cabin button is pushed, normal communication with the flight attendant station is possible. If the cabin button is pushed again, this mode is cancelled. When the light flashes and a chime is audible, a call from the flight attendant has been received. The flight attendant phone enables the cabin crew to communicate with the flight crew, and the second cabin attendant phone, if installed, and to make announcements to the passengers. A push-to-talk switch on the inside of the handset has to be pushed and held down to operate. If the phone is taken off the cradle and the emergency button is pushed, the LED above the button will be flashing, and emergency communication with the flight crew is enabled. If the phone is put back on the cradle, this mode is cancelled. When the flight crew calls the cabin in case of an emergency, a chime will be audible and the LED will be on steady. If the phone is then picked up from the cradle and put back down, the mode is cancelled. If the phone is taken off the cradle and the pilot button is pushed, the LED above the button will be flashing, and normal communication with the flight crew is enabled. If the phone is put back on the cradle, this mode is cancelled. When the flight crew calls the cabin, a chime will be audible, and the LED will be on steady. If the phone is then taken off the cradle and put back on, the mode is cancelled. PA can be selected to make passenger announcements, and the attendant button on the phone is used to call or to receive calls from the second flight attendant phone if installed. The backup interphone mode allows for interphone communication between the pilots and the attendant in case of normal mode failure. When pushed, it illuminates the cabin and cabin emergency buttons on the ICU, and the pilot and emergency pilot annunciators on the attendant's call panel. A striped bar illuminates inside the button to indicate that it has been pressed. The passenger loudspeaker system consists of one loudspeaker located in the ceiling at the main door, one in the ceiling at the service door, one in the right-hand cabinet in the lavatory, and one in each of the passenger service units. There is no loudspeaker in the passenger service unit located at each emergency door. The passenger loudspeakers work in conjunction with the audio entertainment and the passenger address and cabin interphone system. The passenger loudspeakers allow the attendants and flight crew to communicate with other flight crew members and with the passengers. The audio entertainment system is installed on the upper outboard area of the forward galley and provides the flight crew and passengers with safety and flight information. The pre-recorded announcement assembly unit is a computer-controlled, digital voice, multi-language, single-channel passenger briefing system. It provides a convenient and consistent method of informing passengers of important messages, such as safety instructions, takeoff, landing, over water, and other airline information, and also provides the passengers and flight crew with music. In addition, the unit can deliver up to 7 hours of pre-recorded music.
Roger, ready to move out.
A real human voice is digitally recorded and stored directly into the system internal memory. The messages can be spoken in up to 63 different languages. As an option, the unit can be configured to play pre-recorded safety and informational messages in conjunction with pilot or co-pilot actions, such as illuminating a fastened seatbelt or no smoking cabin warning light. To turn the pre-recorded announcement assembly on, the power button has to be pressed and released. A self-test will be performed, and a selection menu will appear on the liquid crystal display. By pushing and releasing the language button, a list of up to 63 different languages is displayed.